Assalamu alaikum YouTubers, welcome back to SLK Tools. Alright, here in this section we'll be talking about steel's calculations just for a circular slab. Alright, it's quite simple and it's the same method we do just for common rectangular or square slab. Let me just assume this guy is a circular slab. Or you can just assume this guy as a circular slab per water tank. Alright. Now here is a question. How much the steel must be distributed? In this palm, it's right quite simple. You may have seen in different places. Now let me just call these guys, say this one length 1, length 2, length 3 and so on. Now how can I find length 1, this guy, this one, length 2, length 3, and you can clearly see these guys are just decreasing gradually. But this is not challenging. You can clearly see the L1, it means length of bar 1, this one, let me call this guy as bar 1, is just the diameter of this slab. What about L2? Now this is little challenging, but it's not. Alright, you can find this guy using Pythagorean's theorem, which is L2 must be r square negative h1 square, and this is of course the Pythagorean's theorem. Here I am not going into Pythagorean's theorem in detail. Alright, for Pythagorean's theorem in detail you can watch in the same channel a video taught named as Pythagorean's theorem. But this formula will just give you the length of this L2, but this will give you half. It means from the center of this length or this line to the edge of this slab. Then what should we do now for overall length of this bar? Alright, it's quite simple. Just multiply this guy with 2. You can get overall length of this bar. What about L3, this one? It's the same problem. Alright, you can use the Pythagorean's theorem, which is L square negative h2 square. Now here is a problem, which is it what is h1 and h2? Alright, it's the same method. Just look over here. H1 is just the distance between L1 and L2. What is H2? It is the distance between L1 and L3. What will be H3? It will be just the distance between L1 and L4, and so on. What will be L4? It's the same method. R square negative h3 square times 2. What is H3? It is just the distance between L1 and L4. This is just a nice formula for calculation of these guys' length, and so on. I think for better understanding we must have an example, alright? But before the example, let me just tell you, when you calculate this half, alright, half slab, these guys steels, then just multiply these guys with 2, you can get this half 2. And this is quite simple in this palm. When you have all these guys and you have the same diameter of bars for temperature bars and the spacing the same, just multiply these guys with 2, you can get temperature bars 2. And this is quite simple. I think let's have an example, alright, to know little better. Alright, here is an example. In this example, we are just asked to calculate only main bars, not temperature bars. And the slab is given, having diameter is 20 feet 2 inch, and the main steel is number 4 at the rate of 6 inch center to center. Also we are informed to take 1 inch concrete cover. Let me just call this guy as slab. And let me just try another circle per concrete cover. It means my steel work will be inside this interior circle, alright? This little guy is just a concrete cover. So all things is given, everything is given, everybody okay. I'll just come straight into solutions. In the solutions, my approach will be calculation per main bars. And this is just right simple. But for main bars calculation, I just need the clear diameter. It means I'll just subtract 2 times concrete cover from this external slab or this external circle. Let me just come over here. The clear diameter of slab must be the external diameter negative 2 times concrete cover. Actually it's the subtraction of concrete cover to one side and another side. Then I can get this guy over here. The clear diameter for bars. What you get? It's 20 and 2 inch. Negative 2 times concrete cover. The concrete cover is only 1 inch. It means I just subtract 2 from this guy. And here is 2. So you can just get 20 feet. Is just the clear diameter of slab. Actually, in common terms, this is not a clear diameter. The clear diameter is just the external diameter. You can call this guy as effective diameter, alright? But no problem, alright? This is just a quantity survey. Now what about L1? Length of this bar 1. It's quite straightforward. L1 must be just the diameter of this interior circle, which is 20 feet. We did a few minutes ago. Now what about L2, L3, L4 and so on? Okay, no problem. Let me just calculate L2. This time we know the formula R square negative H1 square times 2. So just plug in, check in this equation. You must get L2 equals R square. What is R? It is just the radius, alright? The diameter is 20, the radius is must have. So it's 10 square negative H1. What's H1? It is just the distance between L1 and L2, alright? So we are just informed to take 6 inch center to center. It means this is just 0.5 feet. So it's 0.5 square. This will give you the half length of L2. We'll just multiply this guy with 2 per overall length. Do little mathematics with this guy. You must get 19.975, which is less than L1, and it's quite simple. What about L3? This is also minimum just from L2 and L1, and the same formula will be used. R square negative H2 square times 2. Just plug and check in this guy. You must get L3 equals 2 times, what is R? It is 10. Of course it's 10. So 10 square negative H2. What's H2 now? It is the distance between L1 and L3, because we are just gonna calculate L3, alright? So just look at over here. This guy is just 0.5. This one is just 0.5. 0.5 and 0.5 is just 1. It means the distance between L1 and L3 is just 1. So it's 1 square. You must get 19.8997, which is just minimum from this guy. Now what about L4? It is just R square negative L3 square times 2. This guy. And this is also minimum from L3, L2 and L1, and of course you can see it. So plug and check in. You must get the height because we need H3 over here. It is the distance between L1 and L4, because we are just gonna calculate L4, alright? So this is 0.5, 0.5 and 0.5. You must get 1.5 is H3. So plug and check in. You must get 2 times R, which is 10 square, negative H3, it is 1.5 square. You must get 19.73, sorry, 773. It's good. I think to calculate all these guys, this will take a lot of time. So I can say just do the same method for all these guys, L5, L6. What will be the height? It means H4. It is just the distance between L1 and L5. H5, H6, H7, H8, and so on. So do the calculations by yourself. You must get these guys. But here is a question. Till which length or which bar should I calculate? It's just quite simple. Just look at over here. L11 is 17.32 feet. It is much larger. A time will come the length of bar will be just 0 or a negative value. So you must understand that's just the length or the last length. Alright? Does it make sense? Here, let me just show you a picture from my AutoCAD. This one. You can clearly see over here. The last reading is 6.245. And these are much bars, alright? We just calculate, I think 3 bars a few minutes ago, which was 19.899, I think this one, 19.773. So if you are just AutoCAD user, you can get help from AutoCAD too, and that's really amazing. Now just look, this is the calculation per half circle. Just multiply these guys with 2, you must get the same thing per full circle. Actually, this picture is just taken from my AutoCAD, alright? You can use AutoCAD too. And for AutoCAD tutorials, of course, you can watch the same channel, alright? Now just look, these are just main bar's length and these are cutting lengths. When you want to just calculate distributions bar or temperature bar, the same method can be used. And if the bar's diameter and the spacing is just the same, so you can just multiply these guys with 2 to get the temperatures bar. If the spacing and diameter is different from the main bars, and then of course the method is the same, just use the same formula. But in the example, we were just asked to calculate main bars only. So these are just main bars. Let me draw this guy again over here. You can see it better, alright? The text size is little larger than that of, alright? So when I have these guys, the cutting lengths of each bar, just add these guys to get total main steel's length, which is 303 feet, if I am right, alright? This is just 303 feet is just the addition of all these guys. You just add these guys by yourself, alright? I have just summed these guys using my calculator. I might have a little mistake, alright? Therefore, I'm just requesting you to calculate these guys by yourself, alright? So I'll just calculate now the weight of these guys, how much steel is required for main bars. And the weight is quite simple, straightforward. I'll use the same formula I use always, which is d squared divided by 52.9. This will give you the weight of steel per feet in kg, alright? When you multiply this guy with length, this will give you all weight of all length, the steel, alright? So plug and check in, you must get W equals d square, which is 4 square divided by this guy. Why 4? Because in the example we were just informed to take number 4 bar. And here in this formula, the diameter must be in suta. So the bar is just number 4. It means it's number. It means just the diameter is just 4 suta, alright, or 4 by 8 inches. Multiply by 303, which is the length of all these guys. Calculating this guy just this side, you must get 0.30247 from this guy times the length, and bam, the weight is over here. It's 91.6 kg just per main bars. And this is just about 0.09 ton, I think. You just calculate that guy by yourself. So it is it. And what? Nothing. Thank you for watching. See you next time. And wassalam.